All right, hello everyone. So today we have the following. Evaluate the following indefinite integral. Integral 3e to the 4x arctan e to the 2x dx. Typically when I approach a integration problem such as this, I want to pick the easiest technique to use here. And so for example, I'm going to maybe try to use a u sub. Okay, so I'm going to find u here by, I'm going to say u is e to the 2x. Whenever you pick your u, your du should appear in the integrand. Now the du is going to be 2e to the 2x 4x, sorry, 2e to the 2x dx, or 1/2 du equals e to the 2x dx. And that right there, that 1/2 du appears in my integrand. And just bear with me with that. Now, while I'm writing this, I'm gonna say that some people would say, why don't you start with an integration by, integration by parts instead of u substitution? And because some people just see that right away, and I'll get to that kind of like towards the end of the video, if that's all right with everyone. So I'm gonna rewrite that e to the 4x that you see over here as e to the 2x times e to the 2x. So we're using a little bit of algebra. And yes, we are allowed to do that by properties of exponents to split it up. And with what you have here, that e to the 2x times the dx, that's your 1/2 du. So I'm going to rewrite this in blue now. And you would have arctan of u. And then you have a 3e to the 2x, but e to the 2x is u, so this is like saying 3u. And for a second, let's take out the 3/2, which again, we're allowed to do by properties of antiderivatives. Yeah, and you have a problem now that, I can't integrate this off the top of my head, but I think it simplifies the expression that you were integrating in the beginning, okay? And yeah, at this point, I would try an integration by parts. So I would try, I'm going to call instead of u, because u is already used up here, I'm going to use y for what usually called u in integration by parts. So you would have arctangent of u, and then my dv would be u. So v would be u squared over 2, and then my dy is 1 over 1 plus u squared. And I do not take the 3/2, by the way, into consideration for the moment. That's what I do when I'm using integrals. I just kind of take constants out of the way. So u arctangent of u du would equal u squared over 2 times arctan of u, so just applying integration by parts, minus 1/2 u squared over 1 plus u squared. And then, sorry, can't really fit the du in. I apologize about that. Okay, and yeah, I took the 1/2 is coming from that v, I'm taking that out. And one thing I recommend you do if you want to practice your integration by parts, or try to finish this technique that I'm doing, go ahead and pause the video and try to finish it, and then just kind of check back. Now we have u squared divided by 1 plus u squared, which we have to find the antiderivative of. That is an improper fraction because the degree of the numerator is the same as the denominator. So you'd have to use some long division, and you would get, when you do that, 1 minus 1 over 1 plus u squared as your result. Okay? U arctan of u. Okay, and yeah, all I did here, by the way, was say how many times 1 plus u squared goes into u squared. That's it. And if we went ahead and integrated that further, you would get u squared over 2 arctan of u minus 1/2 u minus arctangent of u. Okay, so plus a constant. That's what the antiderivative of 1 is and the 1 over 1 plus u squared. So all of that is equal to u, arctan of u, and 3/2 of that is really what I was trying to integrate. So basically, you would just multiply everything by 3/2 in your answer. So 3/2 u squared over 2 arctangent of u minus 1/2. And yeah, let's just go ahead and, well, I'll just keep it this way. Not too worried right now, but just making our answer nice and pretty here, but you can if you want to. And then, yeah, you'll just replace all your u's now with e to the 2x. So it'd be e to the 2x squared, which is e to the 4x, but I'll just leave it like that. Arctan of e to the 2x minus 1/2 e to the 2x minus arctan e to the 2x plus c. And sorry, yeah, that is arctangent of e to the 2x. Zooming in on that for a second. And that would be it. Now, as I mentioned earlier, why wouldn't I want to do a integration by parts from the beginning? Now, I could have done that. I could have said to myself, you're integrating 3 e to the 4x arctan of e to the x dx. I could have chosen a u here, which would have been arctangent of e to the x. Yeah, because I have to pick that to be u because I don't know the antiderivative or tangent. Sorry, that's e to the 2x. And my dv here would have to be the 3 e to the 4x. And yeah, you could find what du is. Each of the 4x here and your v, and then everything would kind of work out in the same manner that we worked up when I made the u substitution. However, often it is the case that the algebra gets a little tricky a lot of the time when you're doing this, this method right here. So that's why sometimes doing a u sub first and then rewriting your integral to something a little simpler to work with works out real nicely for us. Okay, of course, you're more than it's up to you. You're more than welcome to do the integration the way you want, but just take that into consideration sometimes, that when you're using a u substitution, it makes things a little easier at the beginning. Okay, well, I hope this helps, and thank you very much for your time.